All right, in this video, we're going to have a look at ML systems. Specifically, a very common interview question is around, well, how do we do information retrieval and how do we put this machine learning problem in production? So that's what we're going to tackle today. The particular data set we're going to use a data that's freely available from Stack Overflow. So here's a query that I've put on screen over here. This is a query that I used, and this is a CSV with like 10 inputs that I've shown on screen. So the first step that we're going to do is we're going to firstly describe what is the machine learning model that we want to build. In this particular case, because it's information retrieval, the particular goal that I'm going to describe in terms of what this question is if you put in a query string, like just a random string, return the top n number of documents. So for this particular case, this problem could be a unsupervised problem, or not an unsupervised problem, rather, sorry, but it will be a supervised problem, but you don't really have to define your own labels. It's supervised in the sense that I guess the labels are itself when you feed it into a k-nearest neighbor type model. Right. So yeah, there is a name for these kind of models. I think they're called exemplar models if you are interested in them. In the supervised sense, like you could fit like SVM over them, but that's not really what we're here to discuss. Rather, as you can maybe able to imply from the actual top of the screen, we're going to use KD trees, which is a variant of k-nearest neighbors, and we're also going to use TF-IDF plus SVD, which results in the latent semantic indexing. So how do we set this problem up? So the first thing we need to do is we need to convert the text into a numeric vector. To do that, we define a pipeline. Scikit-learn makes this very easy. So PL is going to be our pipeline. We'll run make pipeline, and we are going to use firstly the TF-IDF vectorizer followed by the truncated SVD. Now in our particular case, because the size of our input data frame is only 10, the maximum number of dimensions we can have is 10. So we're going to set the number of components to be, let's say 8, just so that it's a bit interesting. And then we are going to need to transform our input. So to do that, we will run a fit transform of our input data set, input TF of our content. And let's save that as X. Now to show you that this works, let's have a look at X shape. It's of size 10 by 8 because we have 10 rows. Just so that, because people may not, maybe I'm going too fast, you can see that this input data frame only has 10 rows and 3 columns, which means that when we do this transform, we get 10 rows and 8 columns because I've selected a number of components to be 8. Okay. Then off the back of this, how do we then create something for querying for the information retrieval side? So we're going to use a k-nearest neighbors type model, the KD tree, and how it works is we generate something to, well, I guess, index the particular tree before we then run query. So we can't really throw this into our pipeline, but we can certainly still train a simple model. So let's just use the same notation that they have used, KD tree of X, okay? And then if I want to query it, well, KD tree expects a bunch of numbers. So we need to write something for this query. Let's call this query, and for this query, we need some input text, and we need to select a number of documents that we want to return. So let's say 3 documents, the closest 3 documents. Once we have this, then we need to firstly convert the text into something numeric. Let's go PL transform of our text. Right, so X output is here. And then we need to use this generated text to then query what our model wants. So we want to do a query of X output of n equals 3, and because we only expect text to be like a string. You can probably do an assert here, but I'm not going to bother. And this will return the index. So the index is the second field. Let me double check. Yeah, it returns the distance and the index. We just want the index. So then if we want the actual relevant items from the data set, we need to use like iloc or something to do that. So let's have a look at how this would work and just run some examples. So input df iloc of the query with some text. So the text here in this particular case, let's just say we use bubble pop game, so that we should get the top thing should be index 1. All right. If this works. No, it doesn't, because I can't spell lock. And unexpected keyword argument n. Well, what is this called? It's k is equal to 3. Alright, k equals 3. Unexpected values, expected 2 got 1. So let's have a look at what has gone wrong. I suspect it's because maybe this needs to be like that. I'm not sure. K equals array 3. Okay, so maybe not 0. I should really see what is going on. Print x output. This is why this is a live stream, or close to a live stream, and I think this should work actually. This is the output. Oh, I think it's because I've done that, and I want to get rid of this. And then I actually want to see what this output is. Array, yeah, this is okay. So I actually want this to be a list. And then when I do an iloc, there we go. All right, oh, it wasn't too hard. So this will return, hey, come on. So this will return the 3 closest things. So let's try another example so that we can see that this is working. Let's use the word artificial machine. Should get artificial intelligence machine learning. So this shows you that we already have something in production, if you want to call this that. And you could just throw this into anything that deploys something as an API, right? You just put in some text and you to return the documents that are here. So really, this is all there is in terms of productionizing something very simple, but there's a few outstanding questions. So for example, what do you do about the tags? For example, if you have some kind of business logic whereby you want to predict the tags, and then based on the tags, you want to then come up with a list of similar things, because let's say that you have duplicated questions and we want some diversity in our output, what would that look like? And then in that case, you have a multi-stage pipeline that you want to embed some business logic into it. So there's some considerations there. Of course, you can't really productionize this off a Jupyter notebook either. You probably need to save or pickle this pipeline and pickle this particular object that's created here, the tree and the PL. And then you need to wrap that up somehow in something that is deployable. With all of these questions, I think we will address them in the next video. But in this video, this is really all I wanted to cover, just to give you a taste of, well, how can you do a simple information retrieval type of pipeline, and just think about, or ask some of the questions in terms of how you might productionize it.